interference definition and conditions for interference. What are the requirements for the interference to be produced? So I will repeat out. There should be at least two sources, and those two sources are also the coherent sources. So what are coherent sources? If the phase difference between the waves generating from these two sources are constant over a period, then it is called coherent. The two sources are said to be coherent sources. So it is a mandatory requirement for obtaining interference. And of course, after that, so many other experimental requirements are there. That is the news waves, and the distance between the sources should be small, and the distance between screen and sources should be large, and of course, the background should be dark, and of course, these amplitudes should be equal. This is for mathematical convenience already specified yesterday itself. And of course, this is an important one. The source must be of narrow because the extended source usually cannot generate proper interference patterns. And this is also for mathematical simplification. The sources should be monochromatic. Already we made it clear in the last class. Monochromatic sources are the sources which can produce only single wavelength. Only one wavelength will be generated. So, is there any lag in the completing of the previous class? What is the previous class? Mathematics. Mathematics ఏమైనా ఎక్సెసివ్ అయిందా టైము 2:30 దాటి అయిందా?
సార్ ఇంకా ఫాస్ట్ అయిపోయింది.
అదే ఇంకా 15 minutes అయిపోయింది, ఇంకా అడ్మిషన్స్ అవుతారు, అది కూడా 43 ఓన్లీ స్టిల్. So make sure to know you once again that the attendance will be counted. Online attendance will be counted according to JNT Kakinada. This attendance will be posted as it is in the registers itself. Okay. So you will lose not only lesson but also attendance if you are not attending an online class. Please make sure of it. Okay. Next, and of course, is the definition of principle of superposition. Already we discussed it in detail. Almost in 2 classes we discussed it, principle of superposition. And we are now dealing with the mathematical theory. If two sources are there, y1 and y2, with sinusoidal representations, and like a sine omega t and b sine omega t plus phi, where phi is the phase difference between these two waves. So already we started the analysis. The resultant displacement will be y1 plus y2 according to principle of superposition. So a sine omega t plus b sine omega t plus phi. And I think we analyzed all these things in the last class. I stopped at this point, I think, at equation 5, isn't it?
Equation 5, sir. Yes,
Yes.
sir.
Yes. So r square equals to a square plus b square plus 2ab cos phi. So this is the square of the amplitude. where R is, if you assume that R is the amplitude of resultant wave, that's what actually he has specified. You can observe it. R is the resultant amplitude. Okay, if R is the resultant amplitude and you are noting it as R square, that means it is actually intensity. Amplitude square means that is equal to a square plus b square plus 2ab cos phi. That's what actually you got. Okay, from equations 3 and 4, we have already equations 3 and 4, you define them, r cos theta and r sin theta. And before that, we have this equation a plus b cos phi sin omega t plus b cos omega t sin phi, equation 2. So in this equation, from equation 2, we are rewriting this equation here. In place of a plus b cos phi, you are writing r cos theta, and in case of b sin phi, you are writing r sin theta. The equation is becoming like this. And if you observe this equation, of course r is anyway common factor, you keep it aside. The equation looks like sin a cos b plus cos a sin b. That means is equal to sin of a plus b. So you can write this equation as sin of omega t plus theta. Is it clear?
Yes, sir.
Okay. Then y is equal to r sin omega t plus theta. And of course, you know the value of r here. Already you have r square here. So if you know r square, you can calculate r. R becomes square root of a square plus b square plus 2ab cos phi. That's what actually get it. So you can substitute r value in this equation if you want. So you know y is equal to r sin omega t plus theta. This is actually the resultant wave displacement. Y is the resultant wave displacement. We started here. You see y is equal to y1 plus y2. ఇక్కడ స్టార్ట్ అయ్యాం మనం. సో y ఎంత ఉంటుందని చెప్తున్నారు? r sin omega t plus theta ఫామ్ లో ఉంటుంది అని చెప్తున్నారు. Where r value is square root of a square plus b square plus 2ab cos phi. Okay, then from again equations from equations 3 and 4, from these two equations we just divide these equations 4 by 3. If you do it 4 by 3, equation 4 by 3, what you will get? R sin theta by r cos theta. That means this is tan theta. B sin phi by a plus b cos phi. That's what you got here. B sin phi by a plus b cos phi. Is it clear? If I am going fast, you please raise your hand. You can stop me if you are unable to follow me or understand. No problem. Okay. So tan theta equals to b sin phi by a plus b cos phi. Then theta becomes tan inverse of this function, b sin phi by a plus b cos phi. Okay. Is it clear up to 6th equation?
Yes, sir.
Anybody have any difficulty? Please let me know. So for your reference, already I kept this document in Google Classroom. You can open it there, or you can even download it also. Already I kept this document in Google Classroom.
Yes, sir.
If you want to revise it, or if you want to make any. So, shall I continue? Are there any difficulties?
Yes. No. Continue.
Okay, thank you. Then, so you got y equals to r sin omega t plus theta. This is actually the resultant wave displacement. That means when two waves having displacements y1 and y2 superposing with each other results into a new wave. That new wave will be in the form of y is equal to r sine omega t plus theta. The value of r is given by square root of a square plus b square plus 2ab cos phi, and the value of theta. So we already specified here that theta is the resultant phase. You can see here, theta is the resultant phase. So the value of theta is also derived here. Tan inverse of b sin phi by a plus b cos phi. So all these parameters are known parameters to you. Where a is the amplitude of the first wave, b is the amplitude of the second wave, and phi is the phase between these two waves. So everything is known to you. So you can directly substitute those values here so that you can find out the theta value. And of course, r value also you can calculate. If you know a, b, and phi, you can calculate r also. That means how the resultant wave would be. So now you know what is the displacement and what is the phase. So that means everything regarding the resultant wave is known to you now. Of course, now we will discuss some different cases. So the resultant amplitude actually depending on the amplitude of individual waves anyway. For example, at the time of consideration itself, that means starting point లోనే మనము ఫేజ్ లేదు అనుకున్నాం అనుకో, మనం కాన్స్టెంట్ ఫేజ్ అంటే ఏం చెప్తాం, కోహరెంట్ సోర్సెస్ అంటే ఏం చెప్తున్నాం, రెండు సోర్సెస్ కి మధ్యన ఫేజ్ డిఫరెన్స్ జీరో అయినా అవ్వచ్చు లేదా కాన్స్టెంట్ అయినా ఉండొచ్చు, అంతే కదా. అలాంటప్పుడు 5 may also become 0. There is a possibility, isn't it? For example, if the phase difference between the two waves y1 and y2 is 0, then 5 becomes 0. If phi equals to 0, you can substitute that value directly here in this equation, in this r equation. Resultant amplitude equation lo meer phi value 0 substitute chesaru anko, what will happen? Cos 0. Cos 0 is
1, sir.
then the equation becomes square root of a square plus b square plus 2ab. That is a plus b whole square. So r is equal to square root of a plus b whole square. So it results into r is equal to r square is equal to a plus b whole square, or r is equal to a plus b simply. As we specified earlier, r is the resultant wave amplitude. R is the resultant wave amplitude. You should remember all these parameters. R is the resultant wave amplitude. So r square becomes a plus b whole square. If you replace this amplitude square with intensity, that is I, then the equation becomes I equals to a plus b whole square. So intensity of the resultant wave is a plus b whole square. ఎప్పుడు అవుతుందండి ఇది? Only when phi equals to 0. ఫేజ్ డిఫరెన్స్ లేదు, 0 అయిపోతుంది అనుకుంటున్నప్పుడు ఇంటెన్సిటీ ఆఫ్ ది రిజల్టెంట్ వేవ్ a plus b whole square కి ఈక్వల్ అవుతుంది, వేర్ a and b are amplitudes respectively belongs to first and second waves. Okay, now we will see some conditions of maximum intensity and minimum intensities. So here the condition for the maximum intensity. Already at the time of video lecture itself, I specified when the crest of the first wave falls on the crest of the second wave, the phase difference will be 0.
Yes, sir.
So that condition is repeating here. You see phi is equal to 2n pi, where n can take on values from 0 onwards. So sin n pi value on. How about sin n pi? Sin n pi value antandi
0, sir.
0.
0, sir.
So multiple of any
0,
integer,
sir.
including 0, multiple of any integer results into the maximum intensity. Phi is equal to 2n pi. And at the same time, we also specified that when crest of the first wave falls at the trough of the second wave, the intensity resultant will be depends on an odd multiple of phase. So odd multiple, this is, you can see here, 2n plus or minus 1, 2n plus or minus 1, 2n plus and 2n minus 1 both gives you odd number only. When it is 2n plus 1, here you remember it carefully, listen carefully. When it is 2n plus 1, n starts from 0 onwards. బాగా గుర్తుపెట్టుకోండి, 2n plus 1 తీసుకుంటే n 0 నుంచి స్టార్ట్ అవ్వాలి. n 0 అయితే ఎంత అవుతున్నప్పుడు 2n plus 1 అంటే 1 pi.
1 pi, sir.
సో 1 వేస్తే ఏమవుతుంది 3 pi, 5
3.
pi, 7 pi and so on. That means odd multiple of pi. Okay, but when you choose 2n minus 1 pi, it should be very carefully written. 2n minus 1 of pi and raster anukondi meeru, then you should not include 0 here. The n value should start from 1 onwards only. Is it clear? So these are the conditions for maximum intensity and minimum intensity. Next, now we'll see some cases, important cases. Conditions okay na? Maximum and minimum conditions okay kada? You can observe the maximum
Yes,
when
sir.
the crest of the first wave falls on the crest of the second wave. You will observe the minimum when the crest of the first wave falls on trough of the second wave. Video lecture lo diagram put cheskondi ఒకసారి. I think already I put my lectures also in Google Classroom.
Yes, sir. Yes, sir.
Yes, sir.
If you know, you can go and check there also. Now, case 1. So the first case we are dealing with is constructive interference. Constructive interference always gives you maximum resultant displacement. That is y1 plus y2 వస్తుంది. ఇప్పుడు మీకు constructive interference ఎప్పుడు జరుగుతుందని చెప్పారు, crust falls on another crust. Okay, crust falls on another crust gives you constructive interference. So in this case we are assuming that the amplitudes, resultant amplitudes will give you sum of amplitudes. And for mathematical simplification also, here we are implementing that both the amplitudes of the waves are equal. Initial start and you started here, you see here also the final result also two independent amplitudes to this. You started here A and B, y1 y2, this is y1 and this is y2. So amplitude of the first wave and B is the amplitude of the second wave. Now let us assume that if both the amplitudes are equal, that means A equals to B. When A equals to B, intensity equation ఎంత ఉంది మీకు? A plus B whole square అన్నారు. So A plus A whole square, which results into 4A square. So that is the maximum intensity that you can obtain in an interference pattern. Question ఇలా కూడా అడగొచ్చు. Listen carefully. Show that the maximum intensity of an interference pattern is equal to 4a square. You can obtain a question like that in the university examinations. So in that case, you are supposed to write up to this point. So this is a constructive interference. That's why the amplitudes are being added up. A plus a you are doing. But in case of destructive interference, it will be a minus a. So which results into 0. That is the minimum intensity. So in an interference pattern, the maximum intensity that you can obtain is 4a square only, and the minimum intensity you can obtain is 0. So if you are handling 2 or more waves having same amplitudes, the maximum intensity is 4a square and the minimum intensity is 0. Are we clear?
Yes, sir.
Next, please note down these two relations. These two relations are very, very important relations, which gives you conversion from phase difference to path difference to phase difference. If you know one thing, you can estimate the second one. So phase difference pi equals to 2 pi by lambda into path difference. Of course, if you know one equation, one relation, automatically second relation will come. So path difference equals to lambda by 2 pi into phase difference. You should know these relations. So you'll use them even in not only in interference but also in the next chapter also, diffraction. So after noting down these, let us see first what is phase difference. So of course directly understanding phase difference is difficult because phase concept itself is difficult to understand. So to make it simplified, we will start with understanding what is path difference. If there is a path difference, definitely there exists a phase difference. Okay, path difference ఉన్నది అని చెప్తున్నారంటే డెఫినెట్ గా అక్కడ phase difference కూడా ఉంటుంది. According to these relations, you can estimate them also. Okay, now we'll see what is path difference. For example, say a running race is going on. 3 or 4 members are participating. Let us assume that that is a 100 meters running race. I think you might know that in 100 meters running race, you see, say if this is the starting line, let us assume this is the starting line and this is the ending line. So the separation between them is 100 meters and the participants are here. So once the race started, could you expect each member can reach the end point simultaneously?
No.
So the answer is no. So race start చేసిన వాళ్ళు అందరూ కూడా ఫైనల్ పాయింట్ ఒకే టైంలో రీచ్ అవ్వలేరు. That means, say for example, in interimly, in an intermediate time, Say for example, for the completion of this race, say 10 seconds is maximum limit. It may be an Olympic race. I think you might know that some 9 point something is there. The world record is Usain Bolt, 100 meters. So, for example, after 5 seconds, you consider after 5 seconds of the starting of this running race, some person may be here, and some person may be here, and some person may be here. So now you can understand path difference. There is a path difference between these contestants, isn't it? Time 5 seconds అయిందండి ఇప్పుడు, కానీ 5 seconds లోని వాళ్ళు కవర్ చేసిన డిస్టెన్స్ ఈక్వల్ గా లేదు, అంతేనా?
Yes, sir.
సో దట్స్ వై దేర్ ఎగ్జిస్ట్ ఏ పాత్ రిఫరెన్స్. ఎంత ఉంది పాత్ రిఫరెన్స్ అంటే ఏం చేస్తారు మీరు? ఇక్కడ నుంచి ఇలా ఒక నార్మల్ గీయాలి, అంటే పర్పెండిక్యులర్ లైన్ ఒకటి ఇలా డ్రా చేస్తారు. సో దిస్ విల్ బి ది పాత్ రిఫరెన్స్, అంటే ఈ పర్సన్ ఎడిషనల్ గా ట్రావెల్ చేసిన డిస్టెన్స్ ఇది, అంతే కదా? దిస్ ఈజ్ వాట్ యు ఆర్ కాలింగ్
Yes.
path difference.
Path.
So there is a path difference between the two contestants. The path difference can be estimated simply by drawing a normal from the least traveled person.
Sir, your voice is breaking, sir.
Okay. So now this will become the path difference. So this is the case with some human beings. That is also equally applicable for light race. Light race can also travel in different paths if you force them to do so. Generally, light will travel with velocity of almost 3 lakhs kilometers per second. 3 into 10 power 8 meter per second. The light velocity is the fastest traveling object or thing, whatever you call in the universe to till date. But this light can also travel different paths due to the experimental arrangements. If you make the experimental arrangement like that, the light rays may travel at different paths, may reach the destination in different times. డిఫరెంట్ పాత్స్ ట్రావెల్ చేసి డిఫరెంట్ టైమ్స్ లో మీకు డెస్టినేషన్ రీచ్ అవుతున్నాయంటే డెఫినెట్ గా ఆ లైట్ రేస్ మధ్యన ఏమవ్వాలి? పాత్ డిఫరెన్స్ ఉండాలి. పాత్ డిఫరెన్స్ ఉన్నప్పుడే ఏమవుతుందంటే మీకు ఈ ఇంటర్ఫీరెన్స్ అనేది క్రియేట్ అవ్వడానికి అవకాశం కలుగుతుంది. ఓకే, సో ఆర్ యు క్లియర్ నౌ అబౌట్ పాత్ డిఫరెన్స్?
Yes, sir.
So the next concept is interference in thin films or reflected film. Of course, reflected you keep it side. We will discuss it later. What is reflected? Interference in plane parallel films. So this is actually after introduction. This is the actual topic your syllabus consists. The syllabus the first topic, and actually after introduction, this is the first topic. First, I would like to give you an overview of this thin film. What are these thin films? Why we need to study these thin films? Thin films are maybe laboratory made, may also be naturally available sometimes, or sometimes thin films may also available due to our accidental actions. అంటే ఏంటి ఎగ్జాంపుల్ చెప్తాను చూడండి. soap bubbles. You might observe soap bubbles. Soap bubbles చూసారండి హై మంచి డిటర్జెంట్ విత్ లో మినరల్స్ ఉన్న వాటర్లో మీరు మిక్స్ చేసి అప్పుడు మీకు జనరల్గా ఫోమ్ జనరేట్ అవుతుంది. ఫోమ్ ఈజ్ మేడప్ ఆఫ్ నెంబర్ ఆఫ్ బబుల్స్, ఇజంట్ ఇట్? ఆ సోప్ బబుల్స్ చూస్తుంటారు కదా.
Yes, sir.
So these soap bubble is a best example of a thin film. So why you are calling it thin? Because it is really thin. The film is really thin. The thickness is of the order of micrometers or even angstrom units. So the thickness means the upper layer and lower layer between this gap. The gap between the upper layer and lower layer itself is maximum of few angstroms or few microns. That much thin it is. Even your soap bubble is also of few micrometer thickness. In that soap bubble, you might also observe some colors. Anybody observed anytime?
Yes, sir. Blue.
Many people observed this very common and very effective example. Soap bubbles, particular directions lo meer chusinapudu even the colors are also observed to be changed. మీరు డైరెక్షన్ మార్చుకుంటూ
Just like
ఉంటే
Vipjay, sir.
కలర్స్ చేంజ్ అవుతూ
Vipjay
కనిపిస్తుంది. అబ్జర్వ్ చేశారండి?
sir.
Yes. So
Chesan, sir.
this is the phenomena of interference. That means in that thin film, soap bubble thin film, the interference is taking place. So interference is the reason that is actually causing this colors. Why you are getting colors instead of bright and dark regions? మనం ఇంతకు ముందు చెప్పినట్టుగా బ్రైట్ రీజియన్, డార్క్ రీజియన్, మాక్సిమం ఇంటెన్సిటీ, మినిమం ఇంటెన్సిటీ ఇలా రాకుండా కలర్స్ ఎందుకు వస్తున్నాయి? బికాస్ యు ఆర్ నాట్ యూజింగ్ ఏ మోనోక్రోమాటిక్ సోర్స్. ఇన్ఫాక్ట్ యు ఆర్ నాట్ యూజింగ్ ఎనీ సోర్స్ డైరెక్ట్లీ. ఆ కేసులో మీరు డైరెక్ట్ గా సోర్స్ ఏం యూజ్ చేయట్లేదు. ద సోర్స్ ఈజ్ సన్ ఇట్ సెల్ఫ్. Sunlight is the source, but sunlight is not a monochromatic source. Okay, the sunlight is in fact a polychromatic source, which comprises of several wavelengths, combination of many wavelengths. So that's why you are able to observe a number of colors there. Each color is representing a definite wavelength. This is one example, regularly observed example. So there may some also other examples like when oil or some petroleum products, when they spill on road, a clear road, the cement road or even a BT road, without much dust పార్టికల్స్ తక్కువగా ఉండేటట్టుగా ఉండే రోడ్డు మీద ఎక్కడైనా కొంచెం హైవేస్ ఎస్పెషల్లీ అలాంటి వాటి చోట కానీ ఆయిల్ కానీ లేదా కొన్ని పెట్రోలియం ప్రొడక్ట్స్ కానీ స్పిల్ అయినప్పుడు దెన్ ఆల్సో యూ కెన్ అబ్జర్వ్ ద సేమ్ కలర్స్, ఎస్పెషల్లీ ఆన్ ఎ రైనీ డే. On a rainy day, the spilling oils much like to produce the interference phenomena and exhibiting some colors on road. This is also a very common example. Many authors use it to specify. So all these colors are a consequence of the phenomena of interference that is taking place inside the thin film. So that thin film will be now analyzed mathematically analyze it mathematically, and try to understand how this interference is taking place, how the thin film is able to produce coherent sources. As you know that in order to take place the interference, you should have coherent sources. Then how this thin film is able to produce coherent sources, that will be discussed in this particular topic. Okay, here you should understand this diagram very clearly, and also I suggest you to draw this diagram on your running notes while you are sitting to the physics class, next class only. I will start this in the next class only. So while you are sitting, you should sit along with this diagram in front of you, because I cannot keep this diagram like that forever. As you know, as I am scrolling down, as I want to explain these things, and as I want to explain these mathematical portions, the diagram may not be visible to you, isn't it? So after completion of the class, you better open this document from the Google class and draw this diagram on your running notes and sit along with this, so that it will be helpful to you as well as to me also. Is it clear?
Yes, sir.
First of all, I will try to explain this diagram right now. I will introduce this diagram to you. This is very important topic, as well as the diagram is also very important. Without, you remember one thing, while you are answering this particular question, this is an essay question. While you are answering this question, you cannot write answer without this diagram. If you write the complete mathematical analysis, there is a mathematical analysis. See, the portion of mathematical analysis is there up to here, almost 2 pages of analysis. Don't bother. Very simple mathematical analysis. Don't bother about that. Even you write that complete mathematical analysis without presenting this diagram, you will get 0 marks. So the diagram should be there. Without diagram, you cannot get marks. Remember that. So here, see P and Q. See P and Q, and P prime, Q prime. This constitutes a thin film of thickness T. That's why the heading states that it is a plane parallel film. The parallel film is this is parallel, and this is the thin film. Okay, the thickness of this thin film is T. On either side of this thin film, we have air medium. That means on this side and on this side also there is air medium. In between there is this particular film. We don't know which film is which material is. We don't want that. We don't bother about that. Whatever it may be, the thickness of the film is T, and the refractive index of this particular film is mu. Okay, so now the light ray is incidenting on this thin film, and of course you may wonder why it is how can it be a thin film? This is such a wide representation. This representation is for our understanding. Okay, we cannot go down to the scale of microns and angstrom units. That's why we are drawing this particular diagram on enlarged scale. Okay, this thin film is made up of some material whose refractive index is mu, and thickness of the film is P, and here we assumed that the thickness is uniform throughout the film. On either side of the film there is air medium. Okay, film ki rendu pakkala kuda meeku air medium unnadi. Film thickness P anukuntunnaru, refractive index mu anukuntunnaru. ఇప్పుడు లైట్ దాని మీద ఇన్సిడెంట్ అయినప్పుడు what will happen? So we will discuss it in the next class. Please note down this diagram in your running notes and sit along with that. అది చూస్తే కానీ మీకు అర్థం కాదు. నేను ఎందుకంటే ఇప్పుడు I will say triangle AEC. From triangle AEC I will say here. See, నేను ఇక్కడ జరిపేసిన తర్వాత డయాగ్రామ్ పైకి వెళ్ళిపోయిన తర్వాత ఫ్రమ్ ట్రయాంగిల్ ఏఈసి అంటే మీకు ఎలా తెలుస్తుంది? It may be difficult to understand. So that's why you please sit along with this diagram for the next class. Okay. Next, coming to our Google Classroom status, I think 52 members have joined so far.